Hello everyone, welcome back to this amazing session in which we will be covering the BDA subject. We have actually covered the module 1 so far, and module 2 is the last three topics in which this is the lengthiest topic, and I can say the most important topic as well. So here we have to talk about HDFS. So till now we just saw the introduction to Hadoop and all, but in detail we will be seeing over here what the Hadoop actually does. So in Hadoop we have a particular you can say block or a part that is nothing but HDFS, that is Hadoop distributed file system. Okay, so this it is a storage component which sits above the native files. Okay, so whatever the storage you have or actual thing which you collect and all, above that itself it sits over there. If you look into the diagram of Hadoop component, you will understand very easily. That's there in the textbook. So it is a storage component. It deals with the distributed file system. So in the name itself, distributed file systems there. In the sense, what multiple clusters are there, multiple nodes are there. So it all manages by HDFS. Key points for HDFS. So if it's a storage component which sits over the native file system. And now, what are the key components of Hadoop? So it maintains structured file system, in the sense whatever data you give to Hadoop or to HDFS, suppose any number of data. So let us take an example of 192 MB. Okay, if you take 192 MB and if you divide it into three parts, that is nothing but 64. Okay, 64 MB. So now what it does, it divides this 192 MB file data into three parts and divides it into block A, block B, block C. Okay, so three blocks. Okay, block A, block B, block C. A, B, C. Now what will happen, this particular block will require to divide the data and pass into block A. Before creating the block, what it will do, it will request for three blocks, not A, B, C. Just for A, block A, it will request for three blocks. So you have three blocks. In that, let me remove this B and C. Suppose B is here, somewhere down over here, and C is here. Same way. Okay, A, B, C. So for each block, I want to replicate the data as well. Right? So that's why for each block, I will be asking for three separate blocks. That is for data nodes, three data nodes. So actual block A, actual block B, actual block C, and the copies of it will be saved in the different nodes, just like that. Default block size, it's either 64 MB or 128 MB. Default replication factor, in the sense how many replication nodes should we make, that is 3 over here. Usually it is 2, not in Hadoop, in the sense overall in general worldwide. So but in Hadoop it is 3. Optimus for high throughput. See, high throughput is nothing but amount of work done in a certain time. Suppose there are two things. Okay, some normal other file system does processes 1 GB of data in 1 second, but Hadoop does 1 TB of data in 1 second. So the throughput of Hadoop is more than other, like that. So Hadoop is nothing but that. If you create bigger blocks size, so it will be like less time, less seeking time. So time to process that data is less. That's not high throughput. Fault tolerance, if one node fails, one crashes, you have the replication here, you just use it like that. Works best with large. So millions of MB or very gigabytes of data or terabytes of data can be processed easily with the help of HDFS, Hadoop. So Hadoop daemons. So there are three things: name node, data node, and secondary name node. It's very simple to understand. There is a diagram as well, but I couldn't fit it in the entire board. But you can see that in the textbook, it's very easy for you to understand. What I'll be explaining, from that it will be very easy for you to understand name nodes, such that if you see the diagram, you will remember the diagram as well as the explanation. So what does the name node do? So name node is thing like memory or the brain of the storage system, file system. Like it handles actual everything. So what brain does, commands are neural system and all, everything. What brain gives a signals and all, like that. This name node does. Let us see the characters of name node. So what I did, I couldn't write separately. So for name node, I wrote one. So these things are for name node, these things for data node, and these things for secondary name node. Let us see here. Breaks fall into block. See, we saw right what HDFS does. Name node comes under HDFS. So name node breaks fall into whatever input you get data, you divide it into blocks and then store the replica also. So the breaks fall into blocks. Suppose a file came of 100 MB, it breaks into 30, 30, 30 or 33, 33, equal distribution. Then tracks block location. So wherever the blocks have been stored, it will be tracking that location. So it knows where the block is stored. Manages FS names is nothing but file system cluster. So cluster of files will be managed by this name node. Handles file operation, read, write, create, delete. All these operations will be handled by name node. Uses rack awareness in the sense what the data nodes which are being created. See, name nodes break those input files into different data nodes, right? Into blocks. Those blocks are nothing but like data node itself. Those blocks should be stored somewhere, right? So rack is nothing but shelves type of thing. So if you visit to any hypermarket like D-Mart or any big supermarket, how the items will be stored in rack, one rack, two rack, like the front and back like that. So that's nothing rack. So usually it tries to store the data in the closest rack, nearest rack, and the replication also might be shown in the same rack or in any different rack. It's like just based on the previous existing data nodes. It's just like that. Okay, so use rack awareness. So in which rack which data is stored, everything like that. FS image and edit log. So these are the critical things which a name node handles. FS image is something file system image. So here it stores all the files, okay, of the within the cluster or within the entire system. All the files are stored here. Edit log is nothing but it passes the log information, all the transaction, whatever transaction has been done. Transaction nothing but that any operation completes like a transaction. You would have studied that in DBMS. All the transaction or logs have been observed and sent to the HDFS. Then talking about data node. Data node, what it does, whatever the blocks have been created by name node, that will be stored in data nodes. So each block will be assigned to a particular data node. So if I have to come again to this example, block A, block B, block C. So a block A will be assigned 3 data nodes. So it will request for 3 data nodes, and the 3 data nodes, all 3 will be having the same block A information. Same information, okay? Stores the block, sends heartbeats every 3 seconds. So I just drew that symbol instead of writing heartbeat long, right? Just a shortcut. So in the sense what every data node, it will be sending signals to the name node telling that I'm still alive, every 3 seconds. How are heartbeats per second particular beats are there, but here we'll be talking about different. Here every 3 seconds it will be giving signals, sends heartbeat every 3 seconds to name node telling that I'm alive. Then communicates in pipeline. So whatever the data node is created, every block will be in a sequence. So see, 1, 2, 3, they're next to each other, right? It will be stored like that. Block A, like a pipeline of data. So they'll be communicating like this, double English type. Then multiple DN per cluster. So per cluster there will be multiple data nodes. It can vary into any huge number. Understanding about communicating pipeline we'll see in the diagram. Talking about secondary name node, what secondary name node does, we talk about the FS image and edit log, all the transaction and all the files present. Okay, so what it does, it takes a snapshot of these things. It doesn't take in real time. Whatever the data is actually stored, it will keep on taking the snapshot of that, because by chance if name node fails, we have to use secondary name node. But secondary name node is not a hot standby, in the sense what if name node fails, immediately it won't activate the secondary name node. Manual recovery in the sense what you have to manually recover all the things. Manually you have to active the secondary name node. Same memory requirement. So it's like whatever memory requirement is there for name node, it will have the same memory requirement. Limitations, it's just that it won't be storing the real time information. It won't update the real time things. So whatever is happening in real time, that will be observed by name node, but that won't be replicated or stored in secondary name node. That's the one limitation of that. Talking about the major things which might be asked in the examination potential, that is nothing but file system read and write. So this is the diagram. So this part is the client node, what the client will be having and what will happen in client node, and this is the actual system, what is happening. Let us see. If you want to write, if you want to read all, this is HDFS clients, let it be a server or system. It wants to write, so it will send a open if you want to write something, if you want to read a book, you'll open and then you read, right? So it will send a signal, open function, to the distributed file system. I do not have space, so I have written in the short form. You do not write short form, write in the full form. Make use of the space which is given in the examination booklet. Distributed file system received the open request. So what it does, it tells the name node that I have received the open request, and it requests the name node to get the block location. Suppose I want to read block A, and block A is stored here. So it requests the location of block A, and then it will get the location. Then what it does, after acquiring the location, it will tell the FS data input stream as the input, like, so whatever he wanted to give, so we request the block location, that will be given to this directly. Name node will give that to this. If I have to, this is not in diagram, but I'm just putting like this. So it will give to this. Then we obviously know it's like once we request, now I will go to read. So what it does, HDFS clients request or read function. That function will be given to this FS data input stream. That input stream will understand that he wants to read, and it will directly automates the route or path to the particular data node. Okay, so first it will read this. Once this is complete, or when this finishes, it will read this, it will read this. Okay, so sometimes if you cannot access the, so it will read everything. Okay, it will read this also, and it also read this. So it reads all the data, because FS data input stream is reading all the data just because they are replicates, right? So to know, make sure that all the replications are available. If if it encounters of that one is not there, so it will trigger and replicate another time. Then the user reads like this. Then that is done. Once the user read, then the HDFS client nothing but we user, we request to close a book or file. It will just close it. So that's over. So you have to write. I have put 6 steps, right? 1, 2, 3, 4, 5, 6. So you have to explain all the steps, but you will be writing only 5 points, because 1 individual step, 2 individual step, 3 individual step, 4 and 5 will be together, because here it's not different, it's all the same thing. Then 6 is the individual step, like that. Talking about writing, so if you want to write something, you cannot just open and write, okay? Because it's not like if it is opening, then it already exists. So you can, if you want to write something, you have to create something. So first you have to check whether something already exists I can write, or should I create a new file. So that's why HDFS client I request to create a file that goes to the DFS. Okay, distributed file system takes the create function as input, and it tells the name node, bro, like create me 3 data nodes for this particular thing. So see, I want to write something. For that, I'm not just creating one file. This DFS, I want to create only one file. But what DF is doing, it is actually telling name node to create 3 files, so that it can replicate the data whatever I'm writing and store it. Okay, it creates the 3 name node and tells the FS data stream. And then what happens? See, these 3 nodes are created and they are connected via pipeline, like they communicate via pipeline. Let us understand. We'll see now what happens. Now I'll request for write function. He understands that user client wants to write, and it will give the access to DN. So now what happens? FS data input stream sends 2 packets, okay, like signal, just understand, like 2 signals, write packet and acknowledged packet. Okay, so it sends the write packet. Once the writing is done, the data node should give me a feedback, that is, it is acknowledged, in the sense what successfully written. So whatever I write in data node, that will be automatically returned to data node, another data. So suppose this is data node 1, just for understanding, data node 2 and 3. Once I write in data node 1, it will automatically write in data node 2 and also 3. Then 3 should send the acknowledgement, okay bro, I have successfully written to data node 2. Then data node will send the acknowledgement to data node 1, that okay bro, I have successfully written it. Then this particular data node will send acknowledgement to FS data stream input as well. Once the acknowledgement is given for all the data nodes, then what happened? Client requests to close the file. So client has done, but still one last thing is left for DFS to do, that is, it tells the name node as well that process is complete, the writing work is complete. So now name node can actually update, know the location and store it. So that's all which we have to know about complete thing about 5.10. I will be seeing in the next 5.11 and 12. It's very small thing. I won't be saying that it's much important, but yeah, still if you study, it will be really good for our examination. If there was any disturbance in the video, then I'm just sorry. I'm just helpless, do anything, because I'm all alone by myself. If you have liked this explanation, kindly do like and subscribe. We'll see in the next video.